The intercept is now known if I knew the slope of the regression line. So let's compute the slope. What do we know about the regression line? Y equals m times x plus b, which we know, namely the average of y minus m times the average of x. We can combine x minus the average of x. So that's a more explicit form. So there's just one quantity to determine, namely the slope. Same trick as before. Let's look at the square of the error. Sum over all measurements, how far away from the value on the line. And then form the square. The value on the line is m times xy minus the average of x plus the average of y. For the given xi, this expression says what y should be. This is what we want to minimize. Same idea as before. If you compute the square and compute the sum, you see that this is a quadratic function of m. That is to say, its graph is a quadratic parabola. So we get constants times m, and constants times m squared. And the constant in front of the m squared is positive. So we've got a rough idea how this function looks like. A quadratic parabola that's opened from above. Now we know that the error is minimum if and only if the derivative of this expression is 0. Then we are at the minimum down here. So 0 equals the derivative of this expression with respect to m. This gets somewhat more awkward. That's the sum over all measurements. The outer derivative is 2 times yi minus m times xi minus average x plus y average. Now comes the inner derivative minus xi minus average x. That's the factor in front of the m. So we've got times minus, I put that minus in front, xi minus average of x. That's the derivative with respect to m. And I know if that's 0, I found the minimum, and there's just one. Local minimum, and that's already the global minimum. Let's pull the 2 out of the sum. So we know 0 equals the sum yi minus m times how far the ith x is away from the average y times how distant the ith x is from the average. This was simpler with the computation of the intercept before. Now let's put everything together. Let's form 2 parts. The front one is yi minus the average of y minus m times xi minus the average of x. So this expression is yi minus average of y times xi minus average of x minus m times xi minus average of x times xi minus average of x. This needs to be 0 if I form the sum. So now we know 0 is the sum of how far is y away from its average times how far is x away from its average minus the sum m times the distance of x to its average squared, which looks like a variance if somebody remembers. Now we solve for m because that's the slope we're looking for. M equals, let's bring m to the left hand side. Then we have the crosswise sum yx, or let's do this in the right alphabetic order, xy. Divided by the sum of the squares, xi minus the average of x. That's the slope. That's easy to build if you remember it partially, simply from the physical units. In terms of units, it has to be something like y divided by x, because the slope means what's the change of y divided by what's the change of x. In the numerator, there's 1 power of x. In the denominator, there's 2 powers of x. So, all in all, this looks like it would be difficult to find another expression with this property.